Welcome back to Algebra 1, Chapter 3. This is called Rates, Ratios, and Percents. Now, this is section 3.8 if you're following along in the book. So a rate is something like a certain amount that's used at a certain amount, say amount of time. And this would be like how you could write a rate. You could write it as a fraction. And this is the rate of A per B. So is how you read that, A per B. If you're writing a rate and you use a fraction bar, you read that fraction bar per. And you're familiar with that. You're familiar with miles per hour. That's how fast you can go. Okay. Another thing we have sometimes is called a unit rate. And it would be, say, in your car, if you could get 60 miles per gallon. Now, I told you guys when you write fractions, I want your fraction bars flat as long as it's numbers. But if you're using a rate, if you're doing a rate where it's letters, it's okay to use a slash to mean per. And it also, per means divide. And so we have miles divided by gallons. All of it makes more sense in problems because you're really probably familiar with it. Okay, so here is a word problem. It says, out of the book, it has how much people spend on stuff. And they said the population at the time that they were looking at this in the United States was 266 million. And the people in the U.S. spent 183 billion on clothes, 190 billion in restaurants, and 300 billion at food at home. And so if you wanted to know how much each person was spent per person per year, then notice that this is in million and that's in billion. And we need those to be the same. And to do that, to make billions into millions, you add 3 zeros. So that'd be 183,000 million is sort of how you would read it, but that many million. So if we want to find out how much was spent per person, we do 183,000 divided by 266. The millions of people cross out, leaving dollars, and it's $688 per person were spent per year on clothes. I don't think I spend that much. Maybe I do, but I don't think I do. They said for eating at a restaurant, it was $714 per person. That one might be more than that. We kind of like our Chick-fil-A. And it said food at home was $1,128 per person. I think that's low too for now. I think nowadays, I spend less on clothes and more on food than what those things figured out. All right, the next idea is what's called a conversion factor. The word problem says you have $180, you're going to Mexico and you want to change it into pesos, and the exchange rate is 9.990 pesos per dollar. Whenever you do a conversion factor, you start writing down what you have. So I have $180, there it is, with the units. You write the units of what you have in the denominator because you want those to cancel out. And so dollars go in the denominator. Pesos go in the numerator because that's what I want to change to. Any number in the numerator gets multiplied. That was a terrible multiply. Any number on the bottom gets divided. So you do 180 times 9.99 divided by 1, but to multiply divided by 1 you don't really have to do because it's itself. The dollars cancel out and you're left with 1,798.2 pesos. My husband went on a mission trip to Mexico once, and he said they had some sort of money that was real tiny, the size of the end of your finger. And it was worse that little people didn't pick it up. It would just be on the ground. And he was like, shouldn't we pick this up? And they're like, no, it's not really even worth picking up. So that's kind of weird, isn't it? But imagine, you can see that exchange rate. All right, if you have two things that are fractions on both sides of the equals, the easiest way to solve for x then is to cross multiply and solve for x. So this is a problem in your book, It was about tulip bulbs, and 32 were resistant, I guess to fungus or something, out of 50. So how many would be resistant out of 445? These are two rates we've said equal. We're going to cross multiply and solve for x. The first step I do is I draw my cross to remind me what to do. And I'm going to do 50 times x, so that'll be on one side, and 32 times 4,500 on the other side. So 32 times, so I'm going to have to do it on my calculator, they didn't do it for me. So I do 32 times 4,500 equals, so 50x equals 144,000. Y is x on limits, we multiply by 50. 50. So I do the opposite, I divide by 50, but what I do to one side I do to the other, those cancel out. If I already got that number on my calculator, I could just say divide by 50 and x is equal to 2880. And the last thing you should always do is ask, is it reasonable? 32 is to 50, is 2880 is to 4,500, yeah, that sounds reasonable. If we gotten 6 billion, we know we would have done something wrong. So ask, is it reasonable? All right. Another thing is there's a formula for percents. It's is of equals percent 100. So we have an example problem that we can use with this at the top of page 182. It says, what percent of 15 to 17-year-olds said they are dating? So what is the percent of 15 to 17-year-olds that said they are dating? So what is our number of 15 to 17-year-olds, or 482, out of our total population surveyed, 992. We would cross multiply 482 times 100 on this side, so it'll be 48200 equals 992 times x. Y is x on limits, so we multiply by 992. So we do the opposite, we divide by 992. What you do to one side, you do the other. So it's 48200 divided by 992, and it's 48%. So 48.58, we can round that up to approximately equal to 49%. I hope not. 15, half of them dating. I guess I'm an old fogey thinking that 15 is too young to date. Alright, so that's some things about rate, ratios, and percents. Hopefully it made sense to you. We will come back to this topic again later in the book. So we're just getting an introduction to it now. Hopefully you can pick up some things. Hopefully you already learned some of this in middle school, but if not, you can get it now. It's not that hard, and you'll have more time to look at it later. Alright, math is fun. See you later.